Hello, good afternoon. Thank you everybody for joining. Pleasure talking to you all with one more webinar. And this time we are starting with something on the topic of current interest. Wanted to introduce about CyRAACS and also talk to you about my two distinguished colleagues whom I have here with me. Just a small background about CyRAACS. CyRAACS started in 2017, and we have been in the cybersecurity consulting and advisory space. Have about 350 plus engagements with 150 clients, delivered across industry verticals, across geographies. Our primary lines of business is on the governance, risk and compliance services, risk advisory services, technical services, a packaged option of all these three in managed services mode, and the topic of current interest of the cloud security, and we have a focused need on cloud security. And we have several niche capabilities like forensics and work from home assessments, developed our own homegrown tools like malware analysis and so on and so forth. So we cut across various industry lines in providing our services, anything and everything on the standards. We perform services across all those. For the team who I am Suresh Iyer. I'm the founder and CEO of CyRAACS. I have about 30 years of experience, primarily in the information security space for the last 16 years as a CISO, till about 2017, and 2017 started CyRAACS. I have with me Suresh Ponnuswamy. Suresh Ponnuswamy is a senior application architect and a security architect. He has developed more than 200 plus, architected more than 200 plus applications, security architected more than 400 plus applications, has 2 decades of great experience in the space of application development and cybersecurity, an expert in this space today. He is the Vice President for Technical Services at CyRAACS. I also have with me Anamika Patil. She's our application security specialist. She's involved. She's an offensive security certified professional. She is also a certified ethical hacker, and today leading our application security services in CyRAACS. So the topic of discussion today is on just a minute. The topic of discussion today is on container security. So we're going to start about saying what is containers. We're probably going to applications today are getting delivered in containers. So Suresh, I'm going to ask you, why don't you start and give a background about what is containers, and so that our viewers can now have a view of an understanding of what is containers, and then we can probably drill a little more deeper into that.
Sure, Suresh. Thanks for that. Hi everyone. Good afternoon. I hope this presentation gives you a very good insights into containers and the security that revolves around it. So as you know, in the recent times, the world is moving towards the containerized applications. There's a lot of movement of production workloads that are being moved into cloud, and containers are driving the cloud adoption 2.0 across all major corporations and organizations worldwide. So now when we come to talk about containers, so they are kind of analogous to virtual machines, but then much smaller in size, and they just have whatever is required and necessary to run an application in an isolated and in a contained manner across any operating system. So it's more like having only the dependent libraries and all the application files that are required to run the workloads, and they share the resources in a much efficient and better way rather than a virtual machine could utilize. So when you look at containers, there are various types of containers. The majority of the world today, when they talk about container, they talk about Dockers. So why Dockers? Because the tooling and the orchestration help that is provided for creating and managing Docker containers has become more widespread than any other technology.
So I've heard the Docker, and they've also heard many times they talk about Kubernetes. Now, is Kubernetes also a container solution, or is it?
Yeah. So to run a container in any hypervisor host, you need somebody to manage the containers. So Kubernetes is an orchestrator platform that actually manages your containers. So Kubernetes can actually run Docker containers, it can run Linux containers, it can run many different kinds of containers. So Kubernetes provides you with multiple different kinds of tools which you can use to manage your workloads in a much efficient way, to grow your network or your entire installation of containers, and then manage the entire infrastructure.
So what's the biggest business advantage when they move to the containers?
Yes. So why people are moving towards containerized applications is it becomes much easy and efficient to utilize the resources that are available. For example, if you run 10 virtual machines on a fairly powerful hardware, the limitations of virtual machines by itself reduces the amount of CPU, memory, network, and bandwidth that is available to the host. Whereas if you move towards a containerized applications, probably it will be scaling up to 50 or 60 containers in the same kind of a hardware infrastructure.
So that's the advantage of the scalability and the flexibility that this offers.
Yes.
Great.
Yes. So people have been debating a lot on why we need to move towards containers, or why people are moving to containers in the recent times, because as the world has seen with the latest epidemic and the change in the way which businesses operate has created a lot of traction towards moving to cloud. So cloud 2.0 is what they call, and when we talk about cloud 2.0, moving toward cloud with all your applications becomes much easy when you adopt containers for your application hosting and managing your infrastructure. So what happens in moving to containers? So when your entire development and operation cycle requires
1 minute, I'm having Zishan Ali saying voice is breaking. Is it that I just want to make sure that is it for everybody that the voice is breaking? All right, I'm hearing that it is not. So go ahead and continue. Sorry for disturbing this.
No issues. So what happens in the case of a typical development cycle? So when developers write code according to the business requirements, they just build the solution, they deploy it on some virtual machines or target servers, and they move it to production after testing. So the typical development cycle follows step-by-step approach. But in the case of containers, you have much better advantage because the way the applications are designed is exactly the same way it can run on the target systems. So you really don't have to worry about what would be my target configuration. Will it have the same library version as I'm using, and all other dependencies that are required to run the application. So that is kind of taken care automatically when the containers are used to package your application and then move it to the cloud. So, and it becomes much easy to roll back any changes because you just have to bring down a particular version of your application code base and bring up a new version, and your change is almost instantaneous. So you don't have to go into the configuration part or monitoring any changes that are required, retesting. So your entire operation cycle becomes much faster, and that helps people to roll out code at a much efficient way. So that's the reason people are moving to containers. But not only that, but it also brings in a lot other challenges by adopting to the new way of releasing code into production. So that again brings up new architectural challenges, new security challenges, which we'll be anyway talking about in the forthcoming slides. So we are going to discuss about container security lifecycle and what we can do in terms of securing the application workloads when it gets moved.
So what is the risk of containers? So we know that it gives flexibility. It gives the agility is available.
Right.
Flexibility is there. Now, what are the risks that are introduced because we are now getting into containers, container way of application delivery?
Right. As we have seen, the architecture of container shares the same namespace as the host. So though it is a tad different from a virtual machine, it actually takes away a lot of security layers from a virtual machine, and that actually introduces vulnerabilities and issues by the way it functions. So though it brings in additional better use of your infrastructure, it also adds a lot more issues into your entire lifecycle. So what it means is, like, when you run a containerized application, there are possibilities that the isolation can be broken and your host OS can be accessed, and that actually compromises the other containers that are running in your infrastructure. So, and thereby actually it moves to the other host. So
are they largely configuration related?
Not only configuration related, but also based on the way the containers are built and the way application is designed. So as with any application security requirements, the security has to be looked at a layered methodology. So secure by design is a philosophy where everyone has to adopt for application creation when they want to consider security. It's not like a layer that can be added at a later time, and you can look at security of the entire end-to-end stack. So having said that, so we will be looking into the security considerations, what we can do when we want to create containerized applications, right from building the containers, the securing the containers during runtime, how to store and deploy the containers when we create. So the entire lifecycle part of the security in the containers, and what we can do to effectively monitor and ensure that we have a better and secure operating environment for your containers.
Yeah. See, just a few years back, when the world was migrating from on-prem to cloud brought in a lot of security aspects that we needed to focus on. Similar, there's a new trend that's now happening: containerization and the delivery of application through container. Again, there are important security considerations that you need to do. If you have that, you have a better way to manage your application delivery. So
when we talk about containers, I want to emphasize a few simple points here. Largely to the world, containers are analogous to Dockers, but that's not the case. There are other types of containers. Container is a technology by itself. Docker is an implementation of a container type. So there are Rocket containers or CRAACS.
Photocopy to Xerox.
Yeah, exactly. Yeah, right. Yeah, the same one analogous way. So there are Linux containers. We have CRIO, which is Container Runtime Initiative based containers, and there are unikernels and microkernels. There are various types of containers, and there are orchestration platforms. And again, orchestration platforms, the most well-known orchestration platform is Kubernetes. But that is not the only one. There are other orchestration platforms like Mesos, there are CloudOS, there are Docker Swarm. So they give you all the tools that are necessary to manage your entire container workload efficiently on your target environment. Now, AWS has their own methodology for managing Dockers. They have their own implementation. Similarly, Azure has. Google Cloud Platform has Kubernetes-based clusters where you can build and operate containers. So, having talked about a bit about containers, we will come to the lifecycle. Typical container lifecycle starts with defining the image. So basically, you require an image to create a container. So image is where all your libraries, your kernels, your application code, everything gets added into a predefined format. And once you have created that image, you have to put it into a location where it can be accessed for your orchestration tools. So that is the deployment phase where you look at public and private registries. And there are registries which you can host by yourself. There are registries which are provided by Docker, Quay. So there are a lot of providers who actually give you the necessary infrastructure and platform to host your images. And then you look at how you can orchestrate your images and create containers out of it during runtime. So basically, these three major phases are there in your container lifecycle. So,
Anamika, the question to you: you've done numerous testing in the container environments for our clients. You built, considering the risks that Suresh has pointed out earlier, what are the type of risks that you normally see in the container space?
Okay, so Suresh, what usually happens is, from our client experiences, what I can tell you is clients comes to us only when the containerized applications are in the final runtime phase. When we introduce some vulnerabilities or when we report them to clients, what is the approach which is taken is that they have to backtrack it starting again from the build phase. So our approach or our recommendation would be that if we get the image or if we are assigned the security assessment right from the build stage, we might help them in building a secure image throughout the container lifecycle.
So you're getting it at a later time, gets them to do more work at the design level, back again to get it back to you. So that's the kind of problems that you'll be facing.
That brings us a good point, Anamika. Actually, when an application gets developed and deployed, people look at it only at the development and operations. So they don't consider security as part of their design or development phases. Sure. So the security part, the DevSecOps, actually bridges the gap of adding security into the development lifecycle. So if people start to adopt security right from the build,
security by design.
Security by design, exactly. So that makes it more interesting to have security in place.
So that's a very interesting observation that you're saying, that as we are trying to find out, people have to go back. It's not just about configuration error. You're actually going back and telling them you built it wrongly, go build it differently.
You built it wrongly, you deployed it wrongly, because in deployment also there are various phases. I will be talking about that in the next slide.
So what are the security considerations that you have to keep in mind when you create an image or for a container? So there are certain key points that everyone has to look at when they create the image for any application or when they want to containerize any application. So what are those? So as we are seeing on the slide, there are certain key areas such as securing the build process. So the point which I am going to talk about is more specific to Docker, but it's a generic approach that you can take to create any kind of a container image. So whenever you use any build tools to create a image, you have to look at the best practices that are provided by that particular platform and then create the image, such as not storing the secrets into the container images, not using a higher privileged user as your container runtime user, to remove unwanted services and block unwanted ports that are not used by your application, not storing sensitive information into the images, and then having a proper isolation and access controls for every program that is required for your application, which is part of that image. And then there is a process by which an image is built. So in a typical container creation, what people adopt is they adopt a minimal Linux image. So when they adopt a minimal Linux image, they have to be very sure that the image which they are adopting has to be secure. So, and there has to be like a concise and a very minimal image with all the necessary security patches, and it has to have all the security implementation in place, such as like security enhanced Linux, SE Linux, or App Armor, or secure computing configurations in place, so that it's analogous to how you secure a Linux or a Windows server, where you go by hardening the environment by removing unwanted services, installing firewalls, removing restricting the ports, so installing all the OS patches. So it's almost a similar kind of an approach which you take to build the container. So now we have talked about what are the considerations. Now, what we can do to reduce the attacks, how we can make the container environment in a much better way. So what are the security opportunities that we have got, that we have to consider when we create the container, and how we are going to operate it? So one is we have to look at the reduction of attack surface. So as we have seen, security by design is again a layered approach. So you have to look at your application code that is running inside the container. You have to ensure that the code is properly audited, code review is done, and a secure architecture is followed. Then you have created a container in a secure way. Then you kind of configured your orchestration platform with all the necessary security features in place. And then the host on which this platform is running has to be secure, and the network on which this host is located has to be secure. So each and every layer has to be looked at when you want to reduce the attack surface. Thereby, you have a secure operating environment for your container. And when you talk about immutable architecture, containers are by nature stateless and immutable. What it means is, like, when you create a container, it should not be modifiable. For any application updates, you generally don't go and install patches or update your application code like how we do in a regular VM or a host-based environment. You ignore that image, you create a new image for your new version of the code. So that's how you bring in much better security. Plus, it becomes easy to manage. So when you want to roll back, or when you want to release updates to your
so very dynamic environments would actually really benefit by this kind of so people who are e-commerce companies who want to actually keep rolling offer by the day, by the minute, they'd be much better off by having this kind of
approach. Yeah. So isolation by design is again segregating all your necessary components which are part of your entire lifecycle into respective access control methodologies. And automation and repeatability actually brings in other interesting concept, where infrastructure as code, wherein you can use all your automation tools to create production environments on the go. So you are not having any kind of a vendor lock-in or a hardware lock-in or any kind of a lock-in with respect to running your applications. So when you want to move away from AWS to Azure, you can do it within few minutes if you have all your images properly documented and deployed at registries. You just need the bare OS to run the containerized environments. So these are couple of opportunities which we can look at to make it more secure.
Yeah, I see number of questions that are being asked by Chamundeshwari, Arjun. We will take those questions in the end because we have a limited time and we want to move on. But your questions are noted. Thank you.
So Anamika, you can probably talk about the container security.
Yeah, how are you maintaining your end-to-end posture? How do you maintain a holistic, considering the risks that Suresh has pointed out? How do you expect for our customers today? What is the message that you would like to say from, because you've been directly handling the operational issues for our customers?
Right. So end-to-end container security, from my perspective, to achieve this, organizations' container security program should focus on integrating security in each phase of container lifecycle. Now, starting from the build phase, this is your first phase where it is essential that you primarily focus on the business risks that may arise later during the container lifecycle. To give you a very basic example, like when you are starting to build an image, if you choose an image which is from an untrusted source, the vulnerabilities or the package dependencies which are there for that base image will by default come inside your infrastructure. Also, as Suresh pointed out rightly, the SC technique will enable you to secure your build phase by embedding mandatory access controls and assigning the privilege level at the build phase. So next is the deploy phase. Deploy phase is where the context of the images can be combined with the configurations which are available for your orchestrated services. Now here it is important for organization to achieve compliance through operational best practices. These best practices include seeing that your privilege levels are limited and your role-based access controls are in place. You need to check for the misconfigurations at this phase if there are any, because hardening the applications at the deployment phase is essential. Along with this, there are techniques through which you can make your images immutable. Then moving on to runtime phase, this is a crucial phase wherein the application actually goes inside the production and your live data is exposed to the network, both internal network and the public network. Now here it becomes necessary to ensure that your container runtime applications are secure and also your container infrastructure is secure. So an underlying statement to note here is that it is critical to ensure that not only your container images are secure, but the underlying infrastructure on which you have developed the application is properly configured with the base tools in place. Now, to properly configure it, we also have certain baselines and standards which we will be talking in the next slides.
So we'll just briefly touch upon the package management in containers. So this is part of your build process of creating an image for a container. So that is where most of your vulnerabilities can exist, and we have to actually look at the following configurations, like your container configurations, your packages that you use inside your container, and your application's dependency libraries. So you will look at all those aspects when you want to build the image to make it more secure. So you can run a dependency check, you can look at the issues that are published on the security forums and other places to see what kind of issues that have been discovered in your packages and your libraries which are part of your image. So all these constitute to having a much better and secure image.
So, are there benchmarks today available for containers published from international setups?
Yes, Suresh, there are benchmarks which are available for few of your containers like Docker and Kubernetes. We will discuss about that. Before that, we would also like to focus on why continuous monitoring is important across each layer of your application. As Suresh has rightly pointed out, that at the end, what will happen is that your host OS itself will get compromised. In such scenario, if your host OS itself is compromised, the malicious actor will have access to your entire OS, and in turn, the other containers can also get affected.
So the east-west propagation of
Yes.
the attacker can get more into it.
Expand the attack vector.
Yeah, so the kind of attacks that have happened in the containerized environment is like there have been instances of crypto jacking. So people have got their foothold into one container. They have escaped to the host and they have taken control of the entire host and utilized the host for crypto mining, which kind of resulted in huge bills for a lot of people.
Also, Suresh, I think that in continuous monitoring, this happens mostly when the applications are in runtime phase.
Right.
It is important to have a real-time monitoring solution in place so that any spike in your network or any change in the network traffic can help you identify where the vulnerabilities exactly existed in your runtime application, in your host OS. So yeah, that's when continuous monitoring comes into place. And along with the security components at each layer, it is also essential to look at the resources allocated at each layer inside your containerized application.
Got it. So are you aware of any large scale breach that's happened in the container? I know it's not published yet, but
It's not published, but there have been instances of breaches that has happened because of an insecure container deployed onto the production workload, and people have actually escaped the container's internal security mechanisms, taken over the host on which it's running. And this has happened on a AWS cloud, and one of the customer has received a bill in terms of tunes of thousands of dollars in 1 week, because they have actually spawned more containers, their own rogue containers, which were actually doing crypto mining.
Oh my.
So there have been, so all because of the layers of security weren't configured properly.
Okay. So you were talking about the baselines, right?
Yeah. Now this is a slide which I would have to focus on to talk about baselines. There are various baselines available, and also I think the industry standards are also evolving.
Yes.
So as the container technology is. Now, a few of the baselines which we use while assessing our clients' container security assessment is CIS Docker benchmark, OWASP top 10 for Docker. There is NIST also, which talks about in few section about image risk and registry risk to be specific. There is also CIS for Kubernetes available. Now, these all benchmarks give you a checklist, or you can say test scenarios, which are kind of best practices and which needs to be manually checked against your container images.
So do you have an IOC for each of them, or they're not detailed to the extent that the IOC is built for each one, or do you have recommendations from the benchmarks?
So there are few scripts available, Suraj, which they have given, and there are also recommendations which the baselines and industry standards suggest.
Sorry.
So we can directly impose that on our container applications.
But it's also an evolving space, right?
Yeah, it's a highly evolving space, and people are kind of adapting to the evolution, and Docker has taken the lead by creating the necessary toolset so that the Docker and Kubernetes has become the leaders of the container world, whereas others are still catching up.
So it's very important that that while your decision to move towards container security is very, very important, and you have taken the right decision, make sure that you take this in cognizance and reach out to us if you need any help in understanding the security components and security layering of your container. We'll be glad to help. And I think with this we bring to the close of the webinar. We'll go straight to the question answers now. I know there have been some questions in the chat, but I will first go to the Q&A and then start from there. So we have Manu Sharma. First from Ashlesha. Are we supposed to run our build separately from our production cluster?
Yeah, so actually it's a recommended practice to have your bills created separately, because the bills, once it's created, has to be entered into a repository of registries, whether it is a public or a private registry. You have to follow something called as content trust, wherein you sign your images in a much better way using cryptographic keys and notaries, so it becomes immutable and unchangeable. So what happens is, like, your target orchestration platform has to trust the signing keys, and only those images which are signed by the trusted signing keys are allowed to run in your production environments. And it's a best practice to keep them separate. And it again depends on your DevOps or DevSecOps CI/CD pipelines, how you configure your CI/CD pipelines. So actually that can be looked at to see what would be the best possible way to reduce your time to production, and what's the better way to manage the containers.
Okay, quickly from Ashlesha again, is executable code added to a container image only at the build phase, build time?
It is recommended to have your executable code added to the container at the build phase, because once it's built, the containers have to be made immutable, which means that they have to be used as a read-only method and stateless.
Question from Manu: what are the factors which need to consider when securing containers on AWS?
So you have to look at the security practices which are there for your respective container environment. If you are using Docker, consider the Docker security best practices.
The benchmarks that we
talked about.
So, question from Manu again: what are the parameters to identify attack surface?
So it's a proper threat modeling approach that you have to
Same approach, yeah. So this is no different from, you've got to do the entire threat modeling on the application, on the infrastructure to develop the same. There's nothing specifically for container that we can talk here. NV Srinivasa Rao: can a legacy application not cloud ready be run on cloud using containers?
That depends on the architecture of the application and what dependencies that it needs for execution. So this is an architectural question which has to be which can be answered only after looking at the application.
So it's very specific.
Questions.
But the answer is yes, it can.
It can be.
Yeah. How do you ensure? Question from Mukhan Sharma: how do you ensure base container images are secure and verified?
So when you adopt a base image container, you have to look at the signing keys and the registry from where you are pulling that image. If the images are properly signed by the respective image providers, for example, if it's a Debian image, or if it's an Ubuntu image, or if it's a Alpine image, they have to be properly signed by their GPG keys to ensure the integrity of the images.
Okay. Anuj Dubey: what are the tools used for securing containers? What are the tools?
Okay, so there are tools available, Anuj, for securing containers. I may name few like Docker Security Benchmark. This is a very good tool which scans for all of your CIS benchmark related vulnerabilities. There is Trevi, there is Claire, but we would not recommend you to wholly trust on only automated tools, because for manual testing there are also baselines available which you can refer to.
Is unikernel based container better than Docker container in terms of security? From Ramesh Nair.
This is a very interesting question. Unikernel is again a kind of container technology which has come up in the recent times. And they are a little different from Docker because they don't share the namespace with the underlying host. So they are self-sufficient by themselves, and they don't require an OS or any supporting platform to run. So they are like independent micro VMs kind of an approach. So they are definitely better in terms of security, but then the tool sets that are there for creating unikernels will probably have to be mature to make them more widespread.
From Manu again, is there any software available that can verify the integrity, authenticity, and publication date of all images available on select registries?
There are tool sets that are available with respect to Dockers, where you can actually add the trust factor to add the GPG keys, which can be used to verify the image integrity. So you have to look at it, the kind of registry that you are going to connect to, what are the signing keys, and who are the image providers. So all those things are to be considered when you want to check the image integrity and security.
All right. Arjun Aravind has two questions. Nowadays, containers have the ability to maintain persistent data using volumes. Should this be avoided? And I'll read the second question also. When considering security in the build design process, are there any security patterns that we can apply using coding itself? Or is it limited just securing the container image? What's your opinion? So one on using volumes, and second on what's the should be done in the build design phase itself.
As we have seen, containers are immutable. It's not recommended to store any data inside the containers, but data can be stored, and it has to be stored only by using external volumes. But having said that, the volumes on which the data is being stored has to be secure, and it has to be properly mounted from containers. So there have to be proper ACLs that are in place inside the container for storing and accessing the data. So if the target volumes are secure enough, it can be used for storing the data. And as far as the application security is concerned, you have to look at the application security patterns for developing secure applications.
Okay. One more last question. Is the Docker and Kubernetes used together for containerization, or any one only is used? We already spoke about it, for the benefit of Vatsavachai.
Yeah. So Kubernetes is an orchestration platform. It can run Docker inside Kubernetes, inside pods, and you can run any other type of container inside Kubernetes. It's an orchestration platform which takes care of your container. And Docker can, of course, function independently of Kubernetes.
Okay. Is there any question in the chats that
there are a few questions in the chat? So we will be sharing the recording of this webinar.
Any question that we can take? 44. We will take one more minute to any one question.
Which is better, Docker or Kubernetes?
That's already done.
That is done. Rest are comments.
Yeah.
Okay. So I want to say thank you very much for being listening to this webinar. We enjoyed talking to you all, and thank you, Suresh. Thank you, Anamika, for joining me in this webinar. We from CyRAACS believe that we want to bring to you the latest discussions that are happening in the security space, and make it more relevant to you in your current work that you do. I hope this was a useful session for you. And yet again, till we meet again in one more webinar, thank you very much. It's a pleasure talking to you all.
Thanks, everyone.
Thank you, everyone.